This is problem 2 on exam 2 of module 6 in the book Problem Solving Guide for Electromagnetism and Optics. 5 resistors are connected as shown. 4 of the values are given. There's one of the resistors is unknown. When a 12-volt power supply is hooked up across AB, the current through the power supply is 100 milliamps. Part A, what is the resistance of the unknown resistor? What is the voltage drop across the 80 ohm resistor? What is the voltage drop across the 20 ohm resistor? And finally, part D, if each resistor can pass a current of 2 amps, what's the maximum current that can pass through the battery before one of the resistors burns out? That's a good diagram to begin with. Let's put a battery in there. Okay, there's our battery. Since the current through the battery, the power supply, is 100 milliamps, the equivalent resistance of the circuit must be 120 ohms. You have a 12-volt battery putting a current of 100 milliamps, which is 0.1 amps. The equivalent resistance, the resistance the battery sees, is 120 ohms. So this entire circuit must have a resistance of 120 ohms, and we can use that to get the unknown resistor. There's an 80 ohm resistor here. It's in series with the combination of these 4. So these 4 must combine to be 40 ohms, because 80 ohms in series with the 40 ohms will give 120 ohms. The 20, the 15, and the 25 are all in series. You just add up these 3 resistors, that's a total of 60. So we have 60 ohms in parallel with some unknown resistor, and that combines to give a resistance of 40 ohms. So here's our 2 parallel resistances, the 60 ohm, the unknown, and the equivalent. So here we know the equivalent is 40. This resistance is the unknown resistance. 60 ohms in parallel with an unknown resistor gives a resistance of 40 ohms. So we can solve for R2 by getting a common denominator. 320ths is 220ths plus 1 over R2. R2 must be 120 ohms. So that is 120 ohms. That's part A. We know the current through the 80 ohm resistor is the same as the current through the battery. They're in series. So we know the 80 ohm resistor has a current of 100 milliamps because that's the current through the power supply. So we know the current, we know the resistance, we can get the voltage drop. 8 volts. Since this voltage drop is 8 volts across the 80 ohm resistor, we know this must be 4, and we know these must combine to be 4 because the voltage of the power supply is 12. So there's a couple of ways to get the voltage drop across the 20. That's the next problem, part C. The first is to consider the total voltage drop across these resistance of 60 ohms must be 4 volts. The 20 ohm resistor gets 1/3 of that voltage drop, which is 4/3 of a volt. Another way to get it is to determine how this 100 milliamp current splits at the junction. So we have 100 milliamps coming out of the power supply through the 80 ohm resistor. It splits. Some goes here, some goes here. This branch is only 60 ohms. This branch is 120 ohms. 2/3 of the current will go through this branch. 1/3 will go through this branch. We can start by getting the current here. It's a 120 ohm resistor. It's got a voltage drop of 4 volts because the voltage drop of the power supply is 12 volts, and we know 8 volts is here. So 33.3 milliamps goes here, which means 66.7 must go here because 100 milliamps is coming in. So now we know the current through the 20 ohm resistor. We can calculate the voltage drop. It's IR. Converting to amps, multiply it by the resistance, we get 4/3 of a volt, which we knew already. Just a different way to do it. Now for the final part. If each resistor can pass a current of 2 amps, what's the maximum current that can pass through the battery before one burns out? Well, The 80 ohm resistor gets all the current. When 2 amp is going through the battery, 2 amps is going through the 80 ohm resistor, and it's going to burn out. So the answer is the maximum current that can go through the battery before our resistor burns out is 2 amps, because the 80 ohm resistor gets all the current through the battery. There's no place else for it to go. That's problem 2.